are going to demonstrate to you how to make your own homemade lava lamp. So part of science is learning, wondering, and exploring, just as we have here in our homemade science lab. So I brought along two of my favorite scientists, my daughter Juliet and my son Logan, to help out with this experiment. Or not yet experiment, but demonstration. So to start with, the materials that we've gathered in order to make this, demonstrate to you this lava lamp is, Juliet, what's
So you need a bottle, some red or whatever kind of food coloring you want. We got red food coloring, some water,
and you need 3/4 of a cup of water to complete this. And Logan, what else do we need?
We need a bottle of oil. We need to fill it up to the top. And we also got some
Alka-Seltzer tablets.
Alka-Seltzer tablets.
Which you can just get at your drugstore. Okay, so we're going to begin the demonstration by Juliet is going to pour the 3/4 a cup of water into our clear plastic jug.
I'm just pouring it and my brother's going to help me because this thing's really slippery. Okay, there's the water.
Okay.
Now I'm going to pass it over to him to pour his
So
oil.
next we can add this oil too. We've just put that out to show that it's oil. So we can add that in. And then we're going to continue to fill up the container with some more oil. So we're going to use quite a bit more oil than water for this demonstration. And that should be about good, Logan. Good.
And then
Okay,
I'm going to
now,
put in the...
Next what we're going to do is we're going to just look at how that oil and water are. Now, do you guys see, is the oil and water mixing together?
No!
And why do you think the oil and water don't mix together?
Because the water is lighter than the oil, and the oil is heavier than the water, so
That's right.
they won't compare together.
That's right. And it's something else called intermolecular polarity. So basically, the water is attracted to the water molecules, and the oil is attracted to the oil molecules, but the two don't actually mix together, do they? Okay, so next what we're going to do is you can see, if you zoom in there, you can see that the two have kind of separated. So it's actually looks like we may have put something in the container to separate the two, but in fact it's because of our intermolecular polarity that they won't mix together. Next, just to make this a full effect demonstration, we're going to add some food coloring. You don't necessarily have to add the food coloring, but it's better for to make it more attractive and more fun to add food coloring. So this is a water-based food coloring. So the water-based food coloring should actually just drop down to the bottom. Mix with the water. We'll add about 6 or 7 drops in there. You'll see they'll slowly float down to the bottom. Go through the oil and slowly float down. And once those have floated down, that is when we will add our Alka-Seltzer tablets. We've broken the Alka-Seltzer tablets into pieces just to have it dissolve quicker. And once those Alka-Seltzer, I think you guys can go ahead and drop a couple in.
So me and Logan both have a lot of them.
Just a couple at a time.
1, 2, 3,
Okay,
4.
and we'll let Logan drop some in. And you can see as soon as the tablets go through the oil down to the bottom, the color starts to mix from the food coloring, and the gas exchange begins to happen with those tablets dissolving in the water, pushing up, mixing the colors and creating that lava lamp effect. So pretty cool demonstration, hey guys?
Yeah!
Good. Okay, thank you.
Thumbs up.
Demonstration showing you how to make our own homemade lava lamp, and as you can see here, it's still in full action. We've added a light to make it even more attractive. So one thing we're going to look at now is what's involved in being a scientist. So this particular demonstration that we looked at, we're going to take that demonstration now and turn it into an experiment. And when we look at an experiment, we want the student that we're teaching, we want to really engage them in the activity. So starting off with the demonstration, so keeping things constant, things that are true, things that are tested, and proven knowledge is considered a demonstration. Now making that demonstration into an experiment involves changing one of the constants. And in changing the constants, we have to be secure in knowing that we need to use our senses. It involves our senses when we're looking at changing, because we need to be aware of what changes and the effects of those changes. So we've made this little chart about what a scientist does. So a scientist uses a curious mind for wondering and asking questions. They use their eyes for making observations and saying things like, I see, it looks like. They use their mouths for sharing and finding the facts that they've discovered. I think or I conclude. They also use their feet for exploring and investigating the world around us. So I see, I feel, I smell, I hear, I wonder, I think, really involving those five senses. Hands for writing questions and researching to find answers, and ears for listening and observing as well. So Logan, if you want to come on over here, we're going to again take that lava lamp demonstration and turn it into an experiment. So in order to do that, we have to change something from the constant that we know. So the constant is that we know if we mix a certain amount of water, 3/4 of a cup with oil, fill the oil to the top, we add the food coloring, a water-based food coloring, it sinks to the bottom.
Yeah.
Then what did we add?
Over there.
We added our Alka-Seltzer tablets, it created a gas exchange which caused bubbles, which caused
that we use food coloring to make the bubbles different colors.
Right. So now we have to change something to make that experiment.
Yes.
So now we have to ask ourselves, okay, we know that works, the demonstration works. We have to say, what if, big what ifs, what if we change things?
Like the size?
Like the size of the container. Does it make a difference if we change the size of the container? We pour the...
Yes.
Do you think it does?
Yes, because you can't fit 3/4 of that water into here and then put the rest of the oil in.
Right. What if we use less water? Less oil. Right. Changing that size. What if we used hot water as opposed to room temperature water? What if we used a different kind of oil instead of our regular canola oil? Does it matter if we mix the oil in first and then add the water?
No.
Right, so these are all questions that turn this demonstration into an experiment. The what if questions.